Hi you guys, so today's video, the first one is on Enantiomers. And I know this point or this topic can cause a lot of confusion for students, and a lot of students struggle with this material, and I understand this a lot because back then I also struggled with this material like a lot, and I'll be honest with you. Although it is like hard and it needs imagination and all this stuff, once you get familiar and really are capable of mastering the concepts, we're all good. Okay, so now what are enantiomers? As a briefing, enantiomers are a type of stereoisomers, and today we'll be talking about chirality and the naming of these chiral molecules. Okay, so now that we've touched on chiral molecules, why don't we examine what are chiral molecules? And chiral molecules are molecules or organic compounds that have a chiral carbon, or what we call a chiral center. And what is a chiral carbon or a chiral center? It is a carbon surrounded by four different groups or four different atoms, molecules, whatever. For example, a carbon surrounded by Br and fluorine, an oxygen and a hydrogen. We have four different groups around this one. That's why it is a chiral molecule. Now we have also achiral molecules, and achiral molecules just like the name implies, they are not chiral, meaning they do not have a carbon that has four different groups, and we have a carbon with at least two similar groups around it. Okay, so it is the opposite of being chiral, so it has no chiral centers. And what are enantiomers? Enantiomers are two molecules that have non-superimposable mirror images with respect to each other. And enantiomers are usually chiral, not usually, they're always chiral. So if we have a molecule that's achiral, I'm gonna know directly that it's not an enantiomer. It's not gonna form enantiomers. And actually, I need to point this out. I say about more molecule on its own, it is chiral or achiral, because if it has this carbon or not, it depends on the molecule itself. However, enantiomerism or being an enantiomer is not dependent on one molecule, so I cannot go and say the carbon I have is an enantiomer. It's not like that. So I can, for for me to call this molecule an enantiomer, it should be with respect to another molecule. So enantiomerism is a relationship between two molecules, and a molecule alone cannot be an enantiomer. Okay, so now another point we need to point out is superimposable mirror images are identical molecules, and superimposable mirror images result from achiral molecules, meaning if I give you two molecules that do not have a chiral center and they look like they are mirror images, but if you try and superimpose them or put them on over each other, you'll find that they are superimposed. You're gonna know that actually they're not actually enantiomers. They represent the same identical molecules, and we're going to see this later on. Okay, now this is an example of what we call the enantiomers. If we look here, we have a carbon molecule, we have the hydrogen, we have the bromine, we have the chlorine, we have the fluorine. And if we look at it, for different groups, chiral molecule, therefore, this is probably an enantiomer for this one. Those two are enantiomers and they are mirror images for each other, and this is the first one. And similarly, this one, sorry, is this one is chiral and these two are mirror images. I want to illustrate a real important point over here, because I think this point was confusing to me as a student, and I really tried this exercise in order not to be confused anymore. A lot of professors, they'll be like, rotate the molecule and you'll discover if it is an enantiomer or not. And you might think of it like and say, if I rotate this molecule in a specific way, I'm gonna have this molecule. So if I rotate this one, I might get this one. And I thought about that at first and then was like, let me try and do the exercise. The only way that you might get this molecule is by rotating this like that, just like that, in this direction. Okay, so and let's do it. If I rotate this one, what's gonna happen is that have this carbon, the hydrogen will stay in its place, and that's the H. What's gonna differ is these two groups and this one. The bromine will be over here, and then I'll have the fluorine and the chlorine. And something important that'll dictate the difference, because the fluorine, if I rotate it in this direction, imagine it, it's pointing inwards, and if I rotate it in 180 degrees, it's gonna be pointing outwards. So what's gonna happen is that this fluorine, at first, if you don't draw the fluorine and the chlorine, everything's going to seem like, yeah, I've generated the same molecule, but if you draw the chlorine and the fluorine right, you'll find out that they'll never be the same. And if I draw it, that's a wedge for the fluorine after rotation. And imagine it. Imagine when you rotated the fluorine that's pointing away from you will be pointing towards you, and then the chlorine will probably be pointing away. Look at this. Look at these two. They're not the same, but these two are identical, so it does not matter. Now let me clear this. And this is another example of enantiomers. You probably know this by now. A chiral carbon, chiral center, and mirror images non-superimposable. If you try to put this over this, we're not going to have them superimposed, and therefore they are mirror images and enantiomers. And now let's go to the second slide. Okay, and now there we are. This thing about identical molecules, if I look at those two at first glance, I'm gonna say, oh my god, they're the same molecule, and wow, I got two enantiomers. However, the first point you might notice, someone is gonna say, oh, these two, this one and this one, are achiral because we have two groups, the hydrogen and the hydrogen are similar, and therefore they're not chiral, and therefore this person got it right. Those are not chiral, and therefore I'm gonna know that these two mirror images represent the same molecule. However, someone else might go on and not realize this and be like, I wanna imagine it in space. Like, let's do the same exercise we've done, just the exact same exercise. I'm going to rotate any of these two molecules in space in this direction, or if it was this molecule, in this direction. Okay, and let's do this. I'll do this one. I draw the PR like this. Okay, R. I want to draw the CH3. Oh my god, I messed up with this point. Okay, I'm sorry guys. Okay, I mean, here I should draw the hydrogens. One is a wedge, and which one is the wedge? Okay, which one is the wedge? It's probably the one that was a dashed pond is going to be the wedge, and the key point is always to imagine yourself rotating it in your brain and imagine the positions how they're going to turn out. This is the hydrogen. And this one is going to be inwards, and there we go, inwards. That's our hydrogen, and all we've got left right now is this methyl group, and there we go. I'm going to draw it. The orientation, if it just get like is here now, and we can see now something real important. What happened now? To withdraw this molecule after rotation, what did we generate? We generated this molecule, and there we go. They're just identical, and you can make it a lot easier for you and just say, I have two achiral molecules, and therefore these two mirror images are going to be for sure identical. Okay, I'll clear this. Today I'm gonna touch on one more idea, and I'm gonna leave the naming, which is more complex, to the next video because I don't want to overwhelm you with a lot of info. And next I'm gonna go to an important point about chirality and achirality that is important to highlight. And there we go. Okay, and it is the plane of symmetry and the point of symmetry, or what some call the center of symmetry. Now I'm going to touch first on the plane of symmetry because it's more simple than the center or point of symmetry. And we'll look at this molecule. I'll look at this carbon and this carbon. At first glance, I'm like, they're achiral, and why they're chiral, and why are they chiral? If I look at this one, this is one different group than these three, and these three are different. So I have four different groups around each carbon. Here I have two chiral centers because I have this one and this one. They have four different groups attached around them. What's gonna happen now? You're gonna say this molecule will have a mirror image, and these two are going to be enantiomers, and I'm gonna say it's a no, and you're gonna say why? And this is due to a simple point, is the fact that we have what we call a plane of symmetry. Illustrated here, if I draw this plane, or if you want, just imagine it as a line. This line, I draw it like that. What I'm gonna get is that this part and this part are completely identical, and then what is it? This is achiral, this is an achiral molecule, and the mirror images are identical and not enantiomers, and this is what we call usually mesoforms, and I'm going to explain that further. in the video that will talk about the naming. Now let's go to the point of symmetry. So you will, like, let's agree on something. When a molecule has a double bond, it's not an enantiomer at all, and yeah, but just this one is only done for illustration. So the point of symmetry is simply when I draw a point over here and I go from this point in one direction and I encounter, for example, in this molecule a chlorine, and then I go again from this point in the opposite direction, same way I'm going to also encounter chlorine, and this is what happens in this case. I also go in this direction from the point I'm gonna encounter a hydrogen, and in this point I'm gonna encounter also a hydrogen, and this is what we call a point of symmetry. If we see here, they're aligned in the same way here. However, these are aligned in, I don't want to call it opposite, but if you look at it, there's a line connecting them. A line connecting those two. And this is when what we call having a point of symmetry. And although molecules might be curved, for example, just imagine this double bond not existing. And we have four different groups. Okay, let's say we have a bromine, let's say, or whatever. Okay, and then over here this same or some the same, then we're going to have a point of symmetry. But although this seems to be chiral and will have enantiomers, it won't. Why? Because it has a point of symmetry. Okay, and you guys, that's it for today. I hope this was helpful. I'm going to upload a second video on naming. Please comment any compliance or questions or anything. Bye.